Because today we're going to cover a few different things. We're going to uh, learn what conditions are. We're going to learn how to generate or signal conditions, and we're going to learn how to consume, use, or handle conditions. The thing to understand about conditions is that you don't write conditions to deal with bugs in your code. You write conditions usually to deal with things that can happen that are sort of unexpected and strange. So like common examples are like, your code has to find a bunch of files and maybe it's missing a file. And so it needs to do something about the fact that the file it's looking for is missing. Or if your code interacts with anything over the internet, of course, that's always a fraught process. Lots of ways that that can go wrong. Um, this chapter by Siebel was recommended by Hadley, and I think it kind of captures the situation pretty well. So errors aren't caused by bugs, but you need to handle them, or else you're probably going to have a bug on your hand. Um, Another important thing about conditions and error systems in general is that they help us maintain this illusion of a function as like an encapsulated black box where we don't have to worry about what's happening inside the function. We just know what we put in and we know what we get out. Um, in the kind of famous opinion essay, Go To Considered Harmful by Dijkstra, uh, it's like the whole um uh beginning of the end of people like writing spaghetti code. But even there he said like, yeah, sometimes you need to jump if you're dealing with an error. So like conditions have always kind of been special, and that's been recognized for a long time. In R, there are three types of conditions that we really need to think about. There are a couple of other little ones that we're not going to get into a whole lot today. The main big ones are errors, warnings, and messages. We'll talk about the uses of them shortly. But the thing to understand about conditions is that function authors signal conditions when something happens, and function users handle conditions. And for most of this section, we're going to be talking about signaling and handling conditions. So errors indicate that something happened and we need to stop and we need to deal with it now. And stop is the function that you call in R to signal a condition if you're using base R. They halt execution immediately, and by default, you can see here well, I don't know if you actually see my pointer. Um, when you print an error message, by default, the function that raised the error is prepended to the message. Here I have a little code where f calls g, g raises an error. You can see that this code starting f was executed, this code starting g was executed, but everything else stopped. We didn't finish g, we didn't finish f, we sent an error message. Stop can accept zero or more objects, and if the first object is not a condition object, which we'll talk about later on, it just basically does a paste zero to everything that you send to it, and creates string representations of those and prints that out as the error message. And at the end of the chapter, I have a link to resources where the tidyverse style guide has good guidelines on composing good error messages, which is useful. But um, the stop dots are important to keep in mind because you can paste together a bunch of stuff. You can you know write some stuff and then pass the thing that actually like caused the error if you want to. Um, I showed that the function that raised the error is prepended to the message. You can suppress that with call dot equals false. The dot is not a typo. Hadley pointed out that that dot is not meaningful. It feels like what's that about? But it doesn't mean anything. It's just there. Um, and this chapter was kind of curious because he shared the Erlang alternatives to the base condition things, but he actually used the base R ones in a lot of his code. So Erlang has abort, which signals errors. It has a slightly different interface, and we're going to use it a little bit later on in this chapter. But for the most part, you can generally get away with using stop, and it's just fine. One reason that we might pass call equals false to a call to stop is because it's oftentimes better to just print a traceback and get the whole call stack at the time of your error, especially if you're running code interactively. Um, it's going to give you more information, and it's also specifically going to give you where the error occurred. So the prepended information is a little bit redundant. And so Hadley recommends using stop with call dot equals false. Um, I also like Erlang last trace. It does the same thing with tracebacks, but it has a little bit prettier printing. I'm gonna go back. You see here that it's like it's the stack in reverse order with the most recent call first. Um, and that can be kind of confusing. And here it's shown kind of like as like a little bit of a tree, and that's sort of easier to visualize for me personally. So I like using last trace when I'm inspecting stack traces when I get errors, which is frequent. Now onto warnings. Warnings indicate that a problem occurred, but the function can continue. And what you see here is that the code completed. My code ran through function f and function g, and by default, all the warnings are cached, and then they're all printed out at once when control returns to the top level. And you can change this behavior by setting options warn, but this default behavior is generally pretty useful, and so I tend not to change it myself. Um, Hadley shares the opinion that he thinks that warnings are a little bit overused in base R, and I tend to agree with him. A lot of things that are warnings were probably better off as errors so that you can definitely deal with them, especially things like you know, strings getting converted to NA when you're dealing with like as numeric, for instance. That issues a warning. Probably be better if it was an error, so that you can actually like know for sure that you're okay with dropping some of the values. Um, but in general, he says that you should use it when you're reasonably certain that a problem is recoverable. So if the problem is definitely recoverable, you don't need a warning. And if you're unsure that the problem can be recovered from, that's a case for an error. So warnings kind of occupy this weird space in R. I also want to call out that warning has pretty much the same arguments as stop. It pastes together the things that you pass. Call dot equals true is usually more useful in warning than in stop, um, because um, sorry, I was looking at chat.
Sorry, I didn't mean to distract.
No,
That
it's
was
okay. It's a really
for
good
later
thing.
mostly.
Yeah, no, it's a really good call out. Thanks, John.
Yeah.
Um, but yeah, call.true is usually pretty useful though because the warning message is a little bit further removed potentially from where the warning occurred. And then again, just like there's Erlang abort, there's also Erlang warn. And finally, we come to messages, which you signal with message. By default, they print their output. One thing that's like noteworthy is like with cat, you have to include the new line, but message, it adds the new line for you. And actually, if you peek inside of the message object, the new line is part of that. So it's not just part of the printing, it actually modifies the message itself to include a new line. Another little piece of trivia that isn't really talked about in the book is that if you're using R as like a scripting language, which is not like super common, Messages are passed to standard error, not standard output. And I've been surprised by that a couple times because it feels like a standard output kind of stream, but it actually goes to standard error. So you should definitely think about that um, as you're using messages versus choosing to print something. Um,
Do you have an example for that? I'm sorry, I did not understand that part.
um, let's see here. So, uh, I can try to whip something up here, but we'll come back to that maybe at the end, because I don't want to stop to try to compose an R script on the fly because
Sure, sure, sure. No
we have to
worries.
wait.
That was just, I thought it was
Yeah,
nice to know, but
yeah,
yeah, sure. Continue, please.
yeah, and yeah. To answer your question, Olivier, yeah, cat print. Those are sending things to standard output. Message is sending things to standard error. Um, you could, and we'll talk about this in the next section, um, change that behavior with handlers. And let's go ahead and just get into that. Um, oh, I do want to call out base R has a progress bar built into it. I find that this is something that a lot of my colleagues are surprised by. So you can use messages just to like print a dot every, 100 iterations of a big loop or something. That's quick and easy, and you might want to go for that. But if you want something a little bit fancy that other people are going to have to look at, um, you're probably better off with a progress bar. It's built into R. There are some packages that have better progress bar interfaces, but like it's kind of up to you if the juice is worth the squeeze there. Um, Another little piece of that's noteworthy that didn't make it into the slides is that technically the messages that are generated with package attachment have a little bit of extra metadata into them so that they can be suppressed with suppressed package startup messages. So I think that that's more of a concern in a discussion of our packaging specifically, but there is like a special kind of message that's just this is a message that you print when you attach a package. All right, so let's talk about handling those conditions. And the easiest way to handle the conditions is to ignore them. Um, and in this section, we're going to talk about ignoring errors and ignoring warnings and messages. And ignore means something different in both of these cases. So let me show you what I mean here. So you can ignore errors with try, but when you ignore errors with try, you actually still get the error message, but the code continues to execute after the error. So try says you wrap an expression in try, um, it will print the errors, but it'll just keep going. It won't stop when the function author thought that the function should stop. And for that reason, personally, I think that it's probably you should use try very sparingly because the person who wrote the function thought it should stop here, um, and you could wind up in some weird bug territory by ignoring the author's intent and charging forward with try. I
Doesn't
think that
it
yeah, go
doesn't
ahead.
continue inside of the function? It just continues your code.
It
So it's
does.
not like it, yeah.
Okay,
So it
that
instead
wasn't
of
clear to me.
yeah. So it can be really useful, especially if you're calling something that has an error that you're like, yeah, I know. Like in this case, you might get an error, and I'm just
Mhm.
gonna let you deal with that. And then when
Right.
the error gets thrown, you say, okay, you can have
Yeah.
I'm sure you're going to go into this in a second, but you can do things with that error. It's just
Yeah.
that it won't stop. But
Yeah.
like it won't stop after.
So the code doesn't stop, like your code doesn't stop, but the
Right.
function stops. Okay.
Yeah.
I should have hashed had that. I should have tested that one out a little bit better. Thanks, John. Yeah, thanks for calling that out. In that case, use try to your heart's content. It's great. You know that the errors still happen because you get the message. Um, Hadley recommends this pattern. I like it a lot. It's like a quick and easy way to get a default value in case you're going to deal with something might fail. You just set a variable to the default value. You do the assignment expression inside try. You can silence the error messages by passing the silent argument. And then, you know, the variable that you're assigning retains its default value if an error occurs. But ignoring warnings and messages is a little bit different. Here we're talking about actually just making them quiet and taking them out of your face. And you suppress warnings and messages with suppress warnings and suppress messages. One thing that's always seemed odd to me is like it feels like to me that suppress warnings should suppress warnings and messages. It's like suppress everything, whereas suppress messages is like show me warnings, um, but I don't care about messages. But it doesn't work that way. Suppress warnings suppresses warnings, lets messages through. Suppress messages suppresses warnings. Suppress messages suppresses messages and lets warnings through. You can suppress both by just calling both, or you can set up handlers, which we're going to actually get into right now. So conditions have default behaviors that we've seen. Errors halt execution, warnings are collected and then displayed, and messages are displayed immediately. And all of this can be changed with exiting and calling handlers. And this is the part of the chapter where I learned the very most. So try catch is used to create and change the defaults of the exiting handlers. And so exiting handlers say this code's going to stop, and you can actually tell it when to stop or why to stop. You see here that if I call, I have a function with a try catch in it. If I send something that's not numeric, this gets executed because it's not like, so let's actually do this backwards. When I call my xblog function with a non-numeric value, calling log of x raises an error, and that is handled by the condition handler, which I specify by saying error equals, and then it's a function that takes a condition as an argument. You generally don't necessarily need to do anything with the condition that's passed to that function, although that can be useful. The return value of this function is going to be the return value of the try catch. So if I call xblog with a non-numeric, I get NA, and it stops right here. If I pass a numeric value and log doesn't raise an error, then this gets executed, this gets executed, and this is the default return value. Exiting handlers never return control to the original code. So this snippet shows a few different things, and I want to make sure that I call them out. First off, you can establish exiting handlers for exceptions other than errors. So if I establish an exiting handler for messages, then messages actually cause the code to stop. I can also do the same thing for warnings. I can say like, just stop if you get any kind of signal, by specifying the correct kinds of handlers. So here I establish a exiting handler for messages, and that means messages cause the code to exit. The other thing that's important to look at here is that you can also pass finally to try catch, and then this code is always run after everything else. And this could be really useful for cleanup. If you're creating big objects, or like creating connections, or things like that. If you need to flush a file or whatever, that kind of stuff can go in finally, and it'll happen whether or not an error occurs. Um, with calling handlers specifies calling handlers. So calling handlers, unlike exit handlers, keep running after they catch their signal that they're looking for. So here I establish a calling handler for messages, which means that when this expression has a message, control goes to my message handler, and then it returns back to the function. And generally, the return value of the message handler isn't going to be used very often. You could probably like do an assignment in here if you wanted to, but I haven't seen that pattern in any R code. Has anybody seen that where calling handler return values are used for anything? I, I
Um,
had,
I don't think, um, maybe. I know in Hitter 2, I think it's in like the retry code, or he has some interesting with calling handlers stuff in that package. So maybe in there.
yeah.
Um, I don't like I forget this is a possibility, and I think there are times when I want to do something when when you get a certain type of warning or a certain type of message,
Hmm.
and so this can be really useful. And something that he didn't really point out back with try catch
Hmm.
is um like I don't know if he goes into this at all. I can't remember, but errors can have classes. And so when you
So
say error equals, you can say anything equals.
yeah,
Like you can set up catches for specific types of errors,
I
and
have an
that can
example
be
of that.
super useful.
I
Okay.
have an example of that later on.
Yeah.
Yeah, that was that was the mind-blowing thing from this chapter, and it is going to change how I write my code.
Okay.
Yeah.
Yeah. Yeah.
No,
I
great call
I'm a
out.
big fan of those. Yeah.
Yeah.
Okay.
Yeah, no, we'll come back to that. But that's a great catch. Um, with calling handlers, they bubble up. So if you like you're probably not going to, do this pattern where you wrap with calling handlers inside with calling handlers. But you could definitely wind up with a situation with like this where you have a function that has with calling handlers in it, and it calls a function that calls a function, and that has with calling handlers in it. And handling handling a signal with a calling handler doesn't get rid of it. So, like, if I set up a message handler here, so when I pass a message, this gets called, but I also have a message handler here. So this gets called, and then control flow goes back to the original expression. So when I call message, it jumps up to this message handler, and then it jumps further back to this message handler. Um, and so that's something to keep in mind. Um, on the one hand, that's good for helping maintain, again, the illusion that functions are a black box where you don't need to worry about what happens inside of them. If you want your code to handle all of the signals generated by all of the code um, that it's calling, this is probably like desirable behavior. But if you expect your calling handler to get rid of messages, for instance, it's not necessarily going to do that because the message might bubble up. But you can, of course, change that. Sorry, it also bubbles up to try catch. It's worth noting, but not like super surprising, I think. But the other thing is that you can muffle this bubbling up with condition muffle in Erlang. You can also do this in base R. You don't need to use Erlang to do this, but this is a really simple and useful way. Like if you want to trap messages, if you want to trap warnings and not let them pass to higher up functions, things that are deeper on the call stack, then this works just fine for that. Another thing that's kind of kind of confusing, and I admit that this stack trace is hard for me to get my head around, but um, calling handlers are called in the context of the call that signaled the condition. So this this message handler that I have uh, for the function f is happening within the context of G. Um, we just covered environments, so this makes a little bit more sense. This tells you, um, you know, basically what your environment is going to be, and helps you reason about that if you want to know which variables you're going to be able to get in scope. Um, and this differs from try catch, where exiting handlers are handled in the context of the call to try catch. Um, Hadley says, like, this is weird, and I feel like I need to note it. So just be aware of this. And so now we are, having read the chapter, all aware of this. Finally, this is kind of the last section. I wanted to talk about condition objects themselves, and this is where we're going to get to the cool thing that John pointed out. Um, Built-in conditions, they're just lists with two elements and a class attribute. We, of course, are going to learn about the class attribute when we cover S3 later on. So these are very simple objects. We don't need to worry about object orientation yet because we're not covering it yet, but I think that this is hopefully pretty straightforward. The built-in conditions just have a message and a call. You can access the message with condition message and actually use that in an example earlier on. Um, Call is not generally useful. I don't know if we're going to feel differently about that when we cover metaprogramming, but um, I think, you might want to get inside of a message and, you know, best practices are to use the provided getter. So if you want to get the message of any kind of condition object, you do condition message. And that doesn't just mean, just to be clear, that's not just messages. That's also errors and warnings. They all have this message attribute that's accessible. And here's the cool part. Custom conditions can introduce additional attributes. And I have this here because um, Erlang's conditions, the abort condition, for instance, is really just, and again, we'll learn S3 more. It's an error condition. It's also an Erlang error condition, and it has additional things. In addition to having the message and the call, it has this whole trace object um, that's useful for visualizing good stack traces. Um, and this custom condition thing can be really powerful. So probably the easiest way to create a custom condition is with Erlang abort. Again, you can do it in base R, but the interface is a little bit trickier. It's much simpler to just call Erlang abort. And here I show like you can have a function that calls Erlang abort and like, has nicely formatted messages and stuff. So if I call abort missing file, that will raise a error condition. The message will be based on the file path. You have to use something like glue, or you can call paste yourself because Erlang abort isn't pasting together its arguments the way that stop is. Um, but so like if you want to have like nice, pretty printing of, you want to have like a nice little error factory, you can have something like this. But the real powerful thing here is this first argument to Erlang abort, which is actually the class of the error. And that lets you create specific handlers. And you can do some really cool stuff with this. So for instance, I have my abort missing file. I can have my own CSV reader, for instance, that raises this new custom error if it's missing a file, otherwise it reads the file. That's all pretty straightforward. But now when I wrap it in a try catch, I can catch this error not found error that I just created. And this is exactly what John was talking about. And I can handle that specially. So here I have code where if it reads CSVs, um, and if it can't find the CSV, it returns an empty data frame. And like that might be a pattern that you use. Um, if we're writing all of this code ourselves, we probably wouldn't do that. We would probably just like have this behavior into my CSV reader itself instead of having, this custom error and then handling it specially. But this is really useful for enforcing the principle of the separation of concerns, which is something that, we programmers are supposed to try to do. Um, and what this pattern lets you do is delegate the decision of what constitutes an error to the person who's writing the function. Like as the function author, I'm the one who decides what's an error and what's normal behavior. That's my decision. But the decision about what to do about an error, that belongs to the person who's using the function. And I think that this is probably underused in our packages. I've never used this. Like this is something that I just learned about in this chapter. But I'm actually writing an R package now that might see public release instead of all of my internal ones. And I think that I'm going to definitely throw some custom errors so that, yeah, people can decide what they're going to do if they can't find the file in our API that they're looking for or something like that. So I like this a lot, and you know, please go forth and throw custom conditions. Um, I didn't I didn't put them in the chapter. I now see we probably could have had time to talk about some of the examples. There's a subsection of this chapter that has just kind of like a cookbook of useful things that you can do with try catch. You see how, Hadley includes examples of like how you can write try with try catch or you know, useful patterns for, caching errors and then presenting them at the end or, doing things safely. The per package has a lot of really useful things for dealing with warnings and errors, and a lot of them are basically, uh, neat try catch things. And so I definitely, yeah, I'm sorry I didn't include them here. Like I said, now that I see I have time, but um, it's like just, it's just kind of a grab bag of like cool things that you can do with this stuff now that you understand it a little bit. And finally, just a few other resources. The Erlang vignettes are a pretty good resource. There was a package development masterclass a few years ago that has some useful resources, and that includes a link to the tidyverse style guide for writing good error messages and things like that. Um, but I hope that R's condition system makes a little bit more sense now. And now we have plenty of time for questions or anything that anyone else wants to raise.
I think I have a question. I want to know if I get the main distinction here of like signaling and handling. Signaling is what I'm doing as uh, the person that makes the function, yeah.
Yeah.
And handling is something what I do if I want to bypass the signaling in an other person's function, something like that.
So you're not the only thing that you're bypassing is R's default behavior. So like
Okay.
R's default behavior, if you see an error, is to just stop completely and
Okay.
be done. But you can say, oh, for this kind of error, I don't want to stop completely. I want to keep going with this specific
Okay.
error. And again, that becomes a lot easier if people are raising custom errors, which again, I think we all agree nobody uses, but we're all going to use.
One of the things that, I don't know, kind of blew my mind when I realized it is uh print is what does all of the stuff that you're used to in uh error messages. So when you call a function and you use stop, you are returning an object from your function that is a condition that then prints, and the print does the error, like the thing that you're used to seeing as the error. Um, but it's returning an object, just that both print and I think assign uh,
Right.
handle it separate, especially. But it's just returning that condition object, and so the rlang functions that deal with conditions basically short circuit that and capture that condition object and let you do cool things with it. But yeah, so like that condition object can have attributes, and it can, like, you can do all the things that you can do with any other object. You just have
Yeah.
to be a little bit more careful about it.
Yeah. And we're going to learn more about S3 in a few weeks, but S3 was it was another one of those pieces of art that I was like, yeah, I don't know if I think this is cool. And then I like learned it and I was like, no, actually, I think it's super cool. Um, Ella, you have your hand raised?
Yeah, so I must admit, I skimmed the chapter pretty quickly this morning and was only just made it onto this call about 10 minutes ago. But so this is all still pretty new to me, but I have used classes of errors in combination with test that for checking for specific errors. Are these the same types of classes that we're talking about here? Is that
So
I mean, like, I've used those for the same way, but then you can also use those for handling. And I think technically that's what test that is doing.
right? Okay.
Under the hood, I think it has a try catch that is catching the class of that condition and saying, oh, okay, it is the one I expected, or saying, oh, it's not the one you expected, so I will actually signal that one and tell you about it.
Okay.
yeah, I think
Cool. That's nice to see how these two ideas are sort of aligning.
it's time. We can look at code. Oh,
While you're pulling that up,
Just
I've got a general question for anybody that's using those custom conditions and their errors. If you're doing like a package, how do you advertise that to the end user that there's these custom error conditions that they could potentially utilize, in a try catch or something like that?
a good question. Like, you can see it when you get that kind of error. Um, I've had that global handler thingy turned on for so long, I can't remember what base R does anymore. But it, I think, even in base R, it tells you, like, that class gets included in the message that gets printed. And so once you know about them, like, I notice them, um, and go, oh, okay, I don't need to do just a normal error. I can pass that through, or I can do a special processing of that or whatever. But that's a good question. I think that is it's probably worth calling out somewhere.
Yeah, I wasn't sure if there was documentation spot, if I should be looking for it, or if I'm writing, I should be including it. But it makes some sense that if the class prints the first time you get the error, then that's probably the logical place to start with dealing with it.
Could you make the text a little bit bigger on that console? Sorry, I can't.
yeah,
Yeah,
I
thanks.
bet I could. Let's see.
Come on, plus if you're on a Mac, should do it.
Oh, I am on a Mac. and it doesn't do it.
A quick question.
Thank you.
On the or supplementary question of whatever it is, the customization of log, like you're saying, the customization of errors. Can it be in a very detailed way of, say, for example, cross functional, meaning that if it's a SaaS user, we can customize the warnings in a such a way that he understands, or he or she understands, rather than having a trace on which is reading upside down.
Yeah, well, I think definitely as function authors, we should recognize that writing error and warning messages is part of the user interface of our code, and we probably should put on our user experience hat and try our hardest to realize that the person who's seeing the warnings, try to remember that the person who's seeing warnings has no idea how our code works necessarily, and might not even care how our code works. And we just want to basically people just want to like be told what to do. Like you can't pass that instead. Or I'm warning you that I made this decision for you, but it might not be the right decision for you. So here's the argument that you pass if you want to make the decision yourself. Things like that. But that's just that's hard to do, right? Because when you're writing code, like you're not in the mindset of somebody who's using your code.
That's very true. But what I was thinking is, say for example, the person doesn't know how to use a deploy function, or even he's like very new, he never started using it, and he's from a different programming environment altogether. Can we write a custom function in a function itself so that it tells the user, say for example, you showed that the CSV file is missing, and the regular warning would be different, but if we customize the warning saying that, okay, look, there's a CSV file that you're trying to refer is missing, can we do it for the remaining functions that is happening too? Can we do that way too? And when we do that, do we need to call it separately?
If the question is like, how can we use what we now know about conditions in R to make R friendlier to new R users? I think one thing we could do is, if you were, so for instance, I don't know about what organization you're at, but I think that the agency that I work for, we have a lot of SaaS programmers, but SaaS is being deprecated. So we are onboarding a lot of people onto Python and R who know SaaS. And so there's this big effort to help people get comfortable with this new language and, frankly, a new paradigm, because if you've seen SaaS, it's weird and different than other programming languages. So like, for instance, you could write a package for your SaaS folks that wraps a lot of common operations and catches the most common errors from those operations and prints more friendly error messages for them.
Yes, I am totally with you on that. People who are coming from, I'm just thinking, so wonderful that I heard about this presentation. So I was just wondering if we can go in that way.
Yeah. The other thing you can do is you can set global handlers. And so, but like, setting a global handler means that it's going to catch every warning, every error, every message. And then you would have to do probably some gnarly parsing, because, most errors don't have any kind of customized class information. So that's possible, but probably pretty tricky. And then you would have to like get your global handlers into everybody's R profile.
Okay.
I lost the chat. There we go.
Thank you.
Sorry. So I'm looking at the expect equal, and so I use test that for packet and when I do packages, but I admit that I never really call these functions outside of a testing suite. And one thing I was wondering is if like expect equal would raise an error when things were not equal. And it looks like it's not raising errors. It's just passing some other kind of object. Um,
Yeah,
that is, yeah.
the expectation functions are strange. Like I can't
Yeah. But if you look at,
yeah.
I can't see my cursor because of the way Zoom is.
Will you try expect condition?
Yeah, well, if we expect
And
error,
expect error,
yeah.
expect warning, yeah. All
So it
of
looks
those
like
have class.
expect condition matching is doing a lot of the work.
Yeah.
Can you adjust your screen? I can hardly see the left-hand side of that.
Is that better?
A little better. Now looks better. Yeah. Thank you.
So expect condition matching uses the condition matcher.
This is the rabbit hole of function calling a function calling a function.
Yeah. Well, let's
Yeah.
since I have you here, I'm gonna make you look at try catch. Because it's a beautiful example of R being a Lisp. Like the way that they loop through the expressions that are passed is extremely Lisp code. It always calls try catch one with and then it's like parring and cootering its way through the list of expressions. And so if you've done a lot of C but little Lisp, this seems weird because you would expect to see a loop here instead of recursion. But R is Lispy, and so you see very Lispish patterns. Is there anything else we should look at? Should we try to get standard error? I don't know if I can do this well. Do I have R script?
While you do that, I think like if you look at the documentation, and apparently for what I have seen, error tend to be described at the function level in the documentation under the return tag in R oxygen to answer. But I don't know if you should put that on another level than the function.
Technically, that it is, a condition is returned. So that's probably the best place to put it. But when I said how I try to set up general condition classes and things so that you can at least know, you can set things up to know that it came from my package. And I don't want to put that in every return probably. So I'll have to play around with that idea because it's totally, it is something to point out. It's an interesting thought.
There we go. So message goes to dev null. Yeah, message goes to standard error. So if you're getting rid of errors, you will get rid of messages. But it's much more common that you might do T to output. So the output just gets the standard output. It doesn't get the standard error unless you make sure that you're capturing and redirecting standard error. Not a lot of folks are using R as a scripting language this way. But that message goes to standard error was like a strange gotcha.
Yeah, I use it a lot, and maybe that's why I use cat. And I was blamed for
Depends
using
on
it.
whether, like, I don't know. To me, that makes sense. So the message isn't output of the function; it's information about the function.
Yeah. No, I
So,
mean, well, and the great
like,
thing about this is, oh, go ahead, John.
no, just that's pretty much it. That, like, to me, I can see why it works that way. You want to separate out what the function is normally returning versus what it's signaling. I hadn't thought, and I've read this before, but I hadn't
Can
remembered,
you
I
add
guess,
print?
that you can do funky things with calling handlers. Yeah. Including elevating warnings and messages.
I've never had my terminal this big before. Is it cond message? I don't remember. Let's see if this works. Yeah, all right. Is it condition message? Oh, I have R here. It's condition message. Sorry, folks. Oh, now it's double printing because it's bubbling up.
Yeah. It's crazy. There was a thought I had of, just I don't think the CLI package existed when this book came out, and that's kind of their pretty wrapper around rlang abort, rlang it's not message, whatever, rlang inform, rlang warn.
Okay, now when I do some script and I see it output. See? So in conclusion, it's perfectly reasonable that messages go to standard error. And if you have a problem with that, you can fix it with only 8 lines of code.
Or using
Only a
cat.
small amount of insanity.
Or using cat.
Cool. Yeah,
Well, it was great.
Yeah, I learned a ton from this chapter. That's why it was one I was really stoked to grab. And thanks for your questions. Is there anything else that I missed from chat that we should talk about before we go ahead and stop?
I don't think so. I put a couple examples in chat for things that are interesting. But yeah, this was great.
Yeah, well, thanks so much.
Thank you very much. We do have someone to cover next week. There was a little bit of a chat about the person who was going to present can't be here next week. So, but we're all set. So, yay.
Excellent.
Yep.
Super. See you next week. Thanks, Eamon. Sorry I was so late.
No,
Bye.
thanks for joining.
Bye.
Bye, Al.